During the Thanksgiving holiday, I built a new gaming desktop PC to replace my old one. In fact, I've never bought a brand name desktop PC. I've always built my own because, first of all, it's just a fun process. It's a very interesting thing to do. And secondly, it gives me more flexibility, autonomy to actually control what components I use and to customize it specifically to my needs. This time around, I took a new challenge. I decided to build a silent PC. By that, I'm mainly talking about two noise-related requirements. First, under idle or low load situation, for example, if I'm just watching a, say, 4K video or YouTube or browsing websites or processing documents, under those situations, this computer should be dead silent if I am 3 feet away from it. This is because I shoot video very close to that computer. It's actually right behind me. And this is especially true if I'm shooting something on my desk, which is probably just 4 feet away from that desktop computer. So if the desktop is making noise, it's gonna be picked up in the video. Now the second requirement is that when the PC is under heavy load, for example, playing first-person shooting under high settings or processing videos, rendering videos, under those situations, the computer should still be quite quiet, meaning it's gonna be audible, but people won't really notice it in this room unless they purposefully trying to pay attention to it. So basically, no one will be distracted, and people can do video conference, can do calls, conversations in a normal way. To achieve these, I did a bunch of online research as well as some try and error. I'm happy to report that I actually did it. I'm very happy with this computer I've built. And here I want to share with you all my experiences and findings during this process. And hopefully this will help you if you want to build the same type of silent PC as mine. Let's get started. Let's start with the case. If you have done any research about building a silent PC, you probably have come across those type of cases that's claiming to be soundproofing or sound isolation. Basically, they put some sound isolation material inside the case, claiming to be able to block the sound. Those are good to have, but those should not be the deciding factor for your case purchase. Those are actually more of a marketing purpose implementation. Someone I remember on YouTube has posted a video that this guy actually bought the soundproof case and then they did the measurement of the noise before and after removing that sound material. They just tear it off and do the measurement. And the difference is actually within the margin of error. So those sound isolation material doesn't really make a lot of difference. So what's really important about buying a case for a silent PC is that you need to have a case that have very good ventilation. Like this one I bought, it's the Seasonic Q704. It have opening on the whole top, front, and also the bottom is all open. And you can put 3 fans here, 3 fans here, and you can put 2, I think maybe 1 fan here. This is the power source, so you cannot put a fan here. So that's a lot of fans, and there's a outgoing fan lot at the back of the case. So that's what you're looking for. You want to buy a case that have a lot of places that heat can go out or cool air can come in. You don't really need to buy this specific one. It's sort of expensive. There are cheaper ones that have the same effect, have the same amount of ventilation. So that's what you really need to focus on, the ventilation of the case. Next, let's talk about fans. Fans are the major noise contributor of your PC. There are mainly 4 types of fans in your PC. That would be the CPU fan, the GPU fan, and your case fan, and your power supply fan. Let's start with the power supply. You really can't do much about that fan once you purchased your power supply. So that's why you need to pick your power supply carefully. There are fanless power supplies out there, which doesn't have a fan at all. Seasonic produced several, and I think they can go up to 700 watts, which is good for most of users. On the other hand, these fanless power supply are very expensive. That's why I actually recommend another approach, which is buying those power supplies that have zero fan speed at low load. Basically, if the load of the PC is low, the fan doesn't spin at all. Only when it goes through some threshold, then the fan will start to spin. Seasonic produce a bunch of very good power supplies that have that feature. I think their whole Prime line actually have that feature. And even when the fans spin up, they use this super quiet 135 millimeter fans. I can't even hear that when it's spinning up. So I would really recommend purchasing those. The one I used is actually a little different. This is the Seasonic Connect series power supply, which is made specifically for this case. This is a weird case. It's basically they coupled the power supply with the case to create a better power management, cable management. But it's unnecessary that you purchase this unless you are getting this case too. So yeah, purchase the right power supply to make it quiet, at least from the power supply side. Now let's talk about the GPU. GPU is another one that is basically once you purchase it, you pretty much cannot make much change on the fans. Of course, you can take it apart and put on a aftermarket cooling system, but that's out of the scope of this video, and I am personally also not interested in doing that. So to make right purchases for building a quiet PC or silent PC, there are two features you want about the GPU. One is you want to purchase the brand that have a very quiet fan. Asus and MSI have a very good track of record of making the most quiet GPUs. So you can't go wrong with either of them. But they are very expensive. The other interesting one is the Founders Edition. Founders Edition used to be like terrible choices for making quiet PC because they make a huge amount of noise. However, in the RTX 30 generation, it suddenly improved a lot, and I actually personally have the Founders Edition 3080. The noise level is quite good. I would totally go with it if you can find one, because its price is much lower than the MSI and the Asus, but its noise level is really not that far behind. Another thing that's very important is you want the GPU fans to be zero speed at low load, and that's actually pretty common nowadays. It was not a few years ago, but nowadays if you look at any like GeForce RTX 30 series, they all have this feature. Even the Founders Edition that I get, the fans don't spin at the low load. So that's very important for a totally silent PC. Right. Then the next thing we want to talk about are the CPU fans and the case fans. We can talk about them together because those are the fans that you actually have more control. There are a lot of choices you can make in the market. And the rule of thumb is first, get bigger fans. Like bigger fans are quieter usually because they can spin at low speed and move the same amount of air. All these fans are 140 millimeter. Those are pretty much the biggest that I can put in for this case. And this CPU fan is also a 140 millimeter fan. generally they are very quiet below 400 RPM. So I tried my best to control them at below that amount, that speed, and they can move quite a lot of air. So it's totally good. All the temperatures are good with them. Another thing I want to talk about is the brand. So other than the size, brand is also very important. Some brands are quieter than others. The 3 brands I would recommend is the one I used is Noctua. So that's probably everyone would agree this is the best fans, CPU computer fans that you can get. They are super quiet and they can move air very effectively. Another brand I would recommend is Thermaltake Tough Fan. So those are relatively new products, and they are very close to these Noctua fans. I think at some point Noctua even considered like sue them because they are so similar. So those performance are also very similar. Those are also good fans, the Thermaltake Tough fans. And another one I would also recommend, and I heard a lot of good things about, is the Arctic P series, like Arctic P14 or Arctic P12. So those are also people talking about them as also very quiet fans. There are other brands out there. I don't have much experience, but those 3 I have all like tested before. I have fans from all the 3 brands in the model, so I can venture for them that they are very quiet. Now a little bit more about the CPU fan is that the fan is just one factor for CPU cooling solution. The heat sink itself is also very important. Usually the bigger heat sink is better. They can pull out the heat more effectively. The one I get is actually the quite expensive one, the Noctua NHD15, which I think there are some tests to compare this to the water cooling solution, and they are actually quite comparable. This is probably the best air cooling that you can get, and it's probably also not necessary for everyone unless you have a very high power CPU. Like what I have is the 12th generation Intel 12700, so 12700K. So that's a very high power CPU when it's fully loaded. That's why I bought this one. So all in all, you want a big heat sink so that you can keep the fan noise low. You don't need to blow like crazy through the heat sink to get the heat out. Some people might have thought about using water cooling for CPU or even GPU. Water cooling is great for creating low noise at high load, but air cooling wins at low load noise, because at the low load, fan can be practically inaudible, but the water pump will still have to run, and thus it's audible. So this is basically a trade-off between the noise of high load and the low load. For me, it's more important to have a complete silent PC at low load. So that's why I picked the air cooling solution. Now, one more thing I want to talk about fans that's not directly related to noise is that you need to have more intake fans than outtake fans. The reason is that you want to create a positive pressure inside your case, so that for those places that doesn't have any fans, like here or this area, the air is going outside. Why? Because if you have a negative pressure and the air is coming in, then those places doesn't have filter, right? Air will also come in without going through the filter. It will make your case inside become dirtier. That's why you want to have more intake fans compared to the outtake fans to create this positive pressure inside your case. You can also place your fans a little more strategically, which is, you can see here, my CPU is here and its CPU fans are blowing down. So that's why I put a fan here blowing in, so that the cool air can come into the fan of the GPU and the GPU can pull in the cool air into the GPU. So in most cases, this is an inverse motherboard placement. So in most cases, your GPU will be down here and the blowing up, right? In that case, probably it make more sense to have a fan around this area to blow in the cool air to the GPU. Now, lastly, let's talk a little bit about the hard drive. Well, I actually don't have too much to talk about. There's only one suggestion, which is replace those hard drives using SSD. Hard drives are going to make noise no matter what, especially when they spin up and when they are seeking. The only way is to just replace them with something that doesn't make noise. If you must access large storage, one solution would be to put that into a NAS. I actually have one myself, and I can talk about it in another video. Now we have finished the hardware setup. The next thing would be to fine-tune the fan speed on your computer. There are different ways to reduce noise in software. The most straightforward, most effective way to do it is to tune the fan speed. There are, of course, other ways, like for example, people have been down clock or down voltage their GPU or CPU to reduce the heat generation so that the fans doesn't need to spin as hard. But those are usually more complex to do and less effective compared to fan tuning itself. So here we will only focus on tuning the fans. We'll go through each type of fan again, just like what we did in the hardware part. So starting with the power supply, there is really nothing you can do. You cannot tune power supply fan speed in software. So let's just skip that. And then we'll talk about the GPU fans. So GPU fans, you can tune them. The most popular GPU fan control tool is MSI Afterburner. It is mainly used for overclocking of your GPU, but it also can control the fan speed. If you click that gear and go to the fan tab and you enable your fan control, and you can see now you will be able to adjust your fan curve to control how your fan speed will ramp up or ramp down based on your GPU temperature. Now this looks good, but if you have the newest generation of GPU, what I mean is the RTX 30 series of GPUs, I would actually recommend not to do this. There are two reasons. First, all these RTX 30 series of GPUs, they have zero fan speed when they are at idle, right? Now, if you set this customized curve, that function will somehow not working normally anymore. I have tried to also check this box, which is supposed to fix the problem of the fan never stop, but from my experience, it's still not working as expected. Very often the fan will still be spinning at idle situation. So that's the first problem. The second problem is that if you happen to have the higher end RTX graphic cards like 3080 or 3090, they have the newer GDDR6X, which generates a lot of heat. And now the default fan control will actually take into consideration of the GPU memory's temperature. So if your GDDR6X gets too hot, the fan will actually go up and control that temperature, the memory temperature. Now, if you use this customized curve instead, it will only consider your GPU temperature it's gonna ignore the graphics memory temperature, and that might cause your graphics memory to go to a very high temperature. For those two reasons, I would actually not recommend to use fan control, customized fan control for your relatively new GPUs. Now the next thing we can tune is the CPU fan. And actually I will talk about CPU fan together with the case fan because they can be tuned usually together in the same software. There are mainly two ways to control your CPU and case fans. One way is to control them in your motherboard BIOS. The other method is to use some software in your OS to control the fan speed. Either method has their own advantage and disadvantage. For the BIOS method, the advantage is that it can control the fan speed in very low level, which means as soon as your computer boots, the fan control that you set in your BIOS will take effect. So say if you have multiple OS on your computer, no matter which OS you boot in, that fan control will be the same fan control that you set in your BIOS. Now, the software method has the advantage of being first user-friendly. The interface will be graphics and it's gonna be easier to use. And the other very important advantage of software fine-tuning is that it supports tuning the fan speed based on GPU temperature. And from what I have seen so far, I don't think I have seen a single motherboard that supports the BIOS tuning of fan speed based on GPU temperature. There might be some, but I have never seen them. So that's why eventually I picked the software solution. Now there are a lot of software in Windows that you can use to tune fan speed. Basically, each motherboard manufacturers, they will have their own software that you can download and start to tune the fan speed using that software. There are also many third-party softwares out there. The one I prefer is a little software called the Fan Control. It's this one. See, it's called the Fan Control. I really love its interface. This kind of a panel interface is modern. It shows all the information I care about. And its functionality for defining those fan curves are also awesome. You can not only define just single curves for each fan control, you can even like do booleans. You can combine two fan profiles to create a new profile, or you can do offset of one profile to get another profile. It's just the functionality is very extensive. Now, we will just touch the basics about the methodology of how I tune my fans. Let's take a look at my GPU fan speed. Now I know my CPU fan is a very high quality fan. It's a Noctua 140 millimeter. It generates pretty much no sound below 40%. So when the CPU is at a low temperature, like below 50 degrees C, I'm pretty confident to set it at a very low speed, like 20%. Now above 50%, I will start to ramp it up. But how fast? Well, that depends on how much I want to go at the high end, how comfortable I am with the higher temperature and the fan speed. So 80 degree is something I would sort of at the boundary of what I would start to worry about the CPU. Some people might have a higher threshold, but I think 80 is relatively high already for a CPU. So at 80, I want to set it to some relatively high speed percentage. Here I set it to 75%. Now you might say, hey, how would I know 75% is a good number? This is actually come from some testing. So what I did is I used some stressing software to stress my CPU. For example, here I used CPU ID. It have this function in bench. So you can stress your CPU. You do that, and your CPU will start to ramp up and the temperature will go up, right? You can probably see here, now it's 63, 64. So I will let it run a little bit, and I will listen to the noise. And I will see, well, is the noise too much or is it okay? I will tune this a little bit up or down so that the noise at a stressed situation will still be relatively quiet. So that's basically how you actually tune the higher end temperature of this curve. Yeah, so it's still going up. I think it will go to around 70 degree, if I remember correctly, with my curve. And at that situation, the sound that the CPU fan generates are still pretty good. So that's how I eventually set to this point. So this is basically how you tune your CPU and case fans. Basically, you need to find the temperature that you're comfortable with, and below that temperature, you set the fan speed to be pretty much as low as possible. And then you load your CPU or GPU and using some stress software, and then you tune the higher end of the fan curve to make sure that even at the stressed situation, your system is not generating excessive amount of sound or noise. You can see here, I did that this is for case intake fans, and I have done the curve for CPU and for GPU. I generated actually two curves, and then I combined them into one single profile. Basically, I will take the max speed of those two curves at any situation so that I can ensure that neither my CPU or my GPU will overheat. Another thing to notice is that I also have this exhausting fan profile. If you remember, I have showed you that I have 3 intake fans and only 1 exhausting fan, right? So to counter that imbalance a little bit, I actually set the exhausting fan to spin 15% higher than the intake fan. So that's one more thing that you probably want to pay attention to if you have very imbalanced intake and the exhausting fan like my system. All right, I guess that's all I want to talk about. Hopefully you find something useful in this video, and good luck with your building of a silent PC. I'll see you next time.